Lesson 39, Demo. In this class, we see how to reconstruct a function from its derivative. We also explore the fundamental theorem of calculus part 1. Let f of t represent the value of a stock market investment t months after January of this year. Then f prime of t represents the rate of change of the value of the investment measured in. Now we know the units for the derivative are output units over input units. The output for f of t is the value of the stock market investment. So presumably that's dollars. And then over the units for t is time, and it's months in this case. So the units for f prime are dollars per month. And so let's take a look at this graph over here. We are given the graph of f prime. T is on the horizontal axis, so months, time is passing in months over here. And this graph here, the blue thing, is the rate at which the value of our stock market investment is changing, measured in dollars per month. Let's assume that f of 0 is $100. That means at the start of January of this year, that's the 0, our stock market investment is worth $100, and then we're going to see how it changes over the course of the first 7 months of this year. So let's take a look at the very first month. So in the first month, the stock market's value was changing at a constant $20 per month. And so if the stock market's value is changing at a constant $20 per month over the course of an entire month, then we have gained 20 bucks, right? It's just the value of the increase in our investment. It's just a constant $20 per month for a month. So we've gained $20. So that brings us from 100 up to 120. Let's take a look at month number 2. Hey, excellent. We gained another 20 bucks, right? Because the value of our investment was changing at, again, a constant rate of 20 bucks per month for a month. So from 120, we're now at 140. Okay, let's take a look at this one, the next month. So here to here. Now you can look at this. Now don't despair. That decreasing line doesn't mean we are losing money. That just means the rate at which the money is coming in is going down. But we're actually still making money because this curve is still above the t-axis. So the question is, how much money are we making in that month? Now this one is harder. In the first 2 months, the rate at which the money was coming in was constant for the entire month. It was 20 bucks a month straight. But in this case, in the beginning of this third month, the money is coming in at $20 per month, but then a second later, it's coming in at a little less than $20 per month. And by the end of the month, it's coming in at $10 per month. And so this would appear to be challenging to find actually how much money we gained in that month because the rate at which the money is coming in changes every moment of the month. But we did something like this with the zombies. We just said, okay, well, this is a straight line, so how about we just average it out, right? I mean, like, on average, the money's coming in at a rate of $15 per month for that month. A high of 20, a low of 10, and it's constant rate of change in between. So sure, we could just treat it like it's a straight up 15. But again, we got lucky just because that thing was a straight line. So let's make sure we can do this even if it's not a straight line. 15 is the right answer, it's fine. But let's go back to the very first month. I'll ask you a different question. I won't ask you how much money we made in that month, but instead I will ask you the area of that red rectangle. So the area of the rectangle is base times height. The base in this case is 1, the height is 20. So the area of that rectangle is 20. And wouldn't you know it, 20 bucks is exactly how much money we gained in that month. The area is exactly how much money we gained. And in the very next month, of course, we gain another 20, but 20 happens to be the area of that rectangle too. And in general, the area under the curve and above the horizontal axis is how much money you make. And so if we take a look at that shape, it's a trapezoid. The area of that trapezoid is exactly how much money comes in over the course of that month. I want you to see that you could do this in an analogous way to how we handled the zombie races. You could look at this month from 2 to 3, and we could say, let's overestimate how much money comes in the whole time. Let's pretend it's up here at 20, like constantly 20, and find the area of that whole rectangle. That would be an overestimate. Or let's underestimate it and assume it's constant at 10 and just find the area of that rectangle. That would underestimate it. But really, if you wanted to do this right, you'd maybe cut this month into 2 pieces, and maybe you'd overestimate for the first half of the month and then overestimate for the second half of the month. And maybe instead of 2 pieces, you use 2,000 pieces. But really, ultimately, the sum of all these little rectangles we're putting in here is approaching the actual area under the curve. So when all is said and done, we just need the area inside of that green trapezoid. Okay, so you find the area of that trapezoid. So I'll write it down here, area of a trapezoid. So in a previous class, I didn't use the trapezoid area formula. I cut the shape into a right triangle and a rectangle, and you're welcome to do that here too. But we'll change it up a little bit and do the trapezoid way, direct way. Area of a trapezoid is half the height times the sum of the bases, where the bases are the 2 sides that are parallel. So half of the height. Let's actually skip the height for right now and go to the sum of the bases. The bases are the parallel sides. So the leftmost vertical side is 20, and the rightmost vertical side is 10. Those are the bases. And then the height, I know normally height goes up and down, but you could think of this trapezoid as being on its side. So the height is actually the horizontal distance between 2 and 3, which is just a 1. So in this case, half of 30 is 15. No surprise, we knew we could have just pretended that this thing was like a constant 15 for the entire month, but we decided instead we were going to do it the area way, and I think that's an important connection for us to make here. So we gained $15 more, so we're up at 155. Life is good. Okay, let's take a look at the next shape from 3 to 4. So it's this triangular shape here. It's that area that we're interested in finding. So the area of that one, half the base times the height. The base is 1. The height is 10. So altogether that is a 5. So we just gained another $5, 160. The stock market is fantastic. Okay, let's take a look at between months 4 and 5. Here we go. So this is the triangle whose area we want. Remember, it's not always the stuff below the curve. It's always the stuff between the curve and the horizontal axis. Okay, so the area of that one, half base times height. Base is 1. Base is 1. Height is 20. So that's a 10. So did we just make $10? And the answer is no. The F prime curve is now below the horizontal axis, which means the rate at which our investment's value is changing is negative. So we didn't gain $10 over the course of that month. We lost $10 over the course of that month. And another way to think of that is that anything below the curve corresponds to a negative. If we're thinking of signed area, stuff below the curve we said was negative. So we just lost $10, so we went from 160 back down to 150. Okay, so then going to the next one between 5 and 6. Kind of run out of colors here. I'll go black for this one. So 5 to 6. So we're looking for the area of this trapezoid. Oh goodness, that trapezoid has a large area and it is below the t-axis. So we're losing not just more money, but a lot more money. Okay, so let's do the fancy trapezoid formula again. Okay, so half of the height. Remember the height is from 5 to 6, so that's just a 1. The bases are the parallel sides, so the left base is 20, plus the right base is 40. Ouch. So half of 60 is 30, but again, it's below the axis, so we just lost $30. We were at 150, we lose 30, now we're down to 120. Okay, and now one more. Okay, so the last one we'll do in red again. So we want the area here. And this one's actually really easy because the rate at which the money is going out, the rate at which the value of the investment is changing is constant. It's constantly negative $40 per month. So if you lose at a rate of $40 per month for an entire month, then you have lost $40. But of course, that's the area of that rectangle. 1 times 40, or 40 but it's below, and so we lost. So we went from 120, lost 40. Now we're at 80 bucks, actually less than we started with at the start of the year. I thought the stock market only went up. Okay, so number 3, as we've just seen, the area between the derivative, remember this was an F prime curve, the area between the derivative and the t-axis represents the change in value of the investment over the course of the 7 months. Let's think about that. Suppose that we didn't want to do all of these intermediate calculations, but we just care about, we started at month 0 and we had 100 bucks, and I just care about how much I'm going to end up with at the end of the 7 months. And so without doing all of the intermediate calculations, what if we just found the signed area up here? So all of this space, that's going to be where we gain money, and also all of this space down here, which of course means that we've lost money. So if we just did the total signed area, so we combined the positive stuff above with the negative stuff below, signed area, what would we get? Well, I don't know, you want to do it? Let's take a look at our area calculations. Here we go. I had a 20 and another 20, that's 40. Green one was 15, so that's 55. And then this blue one was another 5. So the area up above was 60. And then down below, I had orange. Where's orange? Slightly off the screen. So the orange one was 10. And then the black one was 30, that's 40. And then the red one over here on the far right was another 40, so that was a total of 80. So the area down here was 80, except it was negative. And so looking at just those two total areas, 60 and negative 80, add them together, you get negative 20. And do you see the negative 20 relationship between our starting number and our ending number? That negative 20, the total combined signed area, from 0 all the way to 7, being negative 20 represents the actual change in the value of our investment over the course of those 7 months. We went from 100, lost 20, we ended up at 80. Okay, so I'm going to get rid of some of the stuff I just wrote there, just to unclutter the picture. Okay, let's come down here. So I'll read that number 3 again. Hopefully it makes more sense now. As we've just seen, the area between the derivative and the t-axis represents the change in value of the investment over the course of the 7 months. We can represent the area with a definite integral. So that's just symbols, right? We know that the integral from 0 to 7 of any function just represents the signed area. And the function in this case was f prime. It was a derivative. But we can also represent the change in value a different way. Suppose that you had everything in the table and you just wanted to know by how much the value of the investment changed over the course of the whole 7 months. What would you do? You would take the $80 and you would subtract the $100. 80 minus 100, that's the negative 20, which was the total change in the value of the investment from the start to the end. But 80 is really just f of 7, right? That's the function value, the value of the investment after 7 months. And f of 0 is the 100. And so the actual change in the value of the investment is clearly f of 7 minus f of 0. But the actual change in the value of the investment is also represented by the area. And so there's 2 different ways to find this actual change. You can do this area calculation to get negative 20. Or you can do the final value minus the beginning value to get negative 20. So putting it together, we have the following statement, that the area, signed area, is exactly the same as the final value of the function minus the starting value of the function. Notice that this is f prime, but these are f's. Really important to have that distinction. Okay, so that statement up above is important enough to have a name. In fact, it has a very important sounding name because it is very important. It is called the Fundamental Theorem of Calculus, Part 1. There are 2 parts to the fundamental theorem. This is the more important one. If f prime is continuous on the closed interval a, b, then the integral from a to b of f prime of t dt is equal to f of b minus f of a. Make sure you see that that is just the general version of exactly what we saw with the stock market investment. In English, the fundamental theorem of calculus says that the area under a derivative, it's got to be f prime inside of that integral. The area under a derivative gives the actual change in the value of the original function. So the area under the derivative gives the change in the original. An important fact you'll use in the activity, the units for the integral from a to b of g of t dt are the product of the g units and the t units, which is kind of easy to remember because you can just imagine there's an invisible and implied multiplication symbol in between. So this really does look like g times something with t. Okay, so let's do one application here. The rate of flow of oil through a pipe is given by f prime of t equals t times 2 plus sine t over 3 plus t gallons per minute at time t minutes. Let's use technology to find the amount of oil passing through the pipe in the first 20 minutes. Okay, first thing I want to do is use technology to graph this thing. So let's take a look at the graph. I'm going to y equals x parentheses 2 plus sine x. I hit the sine button, better make sure we're in radian mode. Okay, that looks good. Divided by, open parentheses, 3 plus x. Okay, standard window is not what I want here because we want the first 20 minutes. So we're going to go 0 to 20. I'm actually going to go 0. Actually, I'm going to go -5 to 25 just so we see a little bit extra here. We can go by 5s. And then here, I'm not 100% what these are supposed to be. I'm just going to plug in a couple of numbers. If I plug in 0 for all these t's, then I get 0 on the top and then 3 on the bottom. So I got to include 0 here. And if I plug in 20, then I get, let's see, so sine of 20, I don't happen to know sine of 20 radians, but it's not any more than 1. So this part isn't any more than 3, 2 plus 1. And this is a 20, so 3 times 20 is 60. Divided by, and then 3 plus 20 divided by 23. So 60 divided by 23 is roughly 3. So I don't know, maybe 0 to 5 or something would be okay. I'll do like -2 to 5. It's okay if we're not perfect here, but that's a way to get a sense of what the graph looks like. Okay, that looks good. Vertical asymptote here is at t equals -3. Not surprised, but that's not part of our region. We're just going the first 20 minutes. So starting here, and going over here to 20 minutes right there. And so this thing right here represents the rate at which oil is flowing through a pipe, gallons per minute after t minutes. So the oil is flowing through the pipe at, I don't know, is this a 1 right here? 1 gallon per minute at this moment. And then it slows down. It's still flowing through the pipe, but maybe only at like half of a gallon per minute. And then it speeds up. And up here, it's flowing through the pipe at like 2.2 gallons per minute, and then it slows down to like 0.8 gallons per minute. So it's always flowing through the pipe, but it's speeding up and it's slowing down and it's speeding up, generally speeding up, it looks like. Okay, so how are we going to find the amount of oil passing through the pipe? Well, the amount of oil, if F prime is the rate of flow of oil, then F is the amount of oil. In the first 2 minutes. So that's a cumulative count of the amount of oil passing through. And so I guess what I'm really interested in knowing, so it says how much passes through in the first 20 minutes. So I think what I want to know is how much is F of 20, right? That's going to tell me how much oil passed through in the first 20 minutes. Now, I'm also going to put F of 0 here because this, I mean, it's the first 20 minutes, right? So that means that 0 is important. And presumably, because this is a cumulative function, F of 0 is 0, like no oil has passed through at the moment we start the clock. But I'm hoping that you buy F of 20 minus F of 0 is a good thing to write. So that would tell us to take the amount of oil that's passed through in the first 20 minutes and then subtract off the amount of oil that passed through in the first 0 minutes, which of course is nothing, but F of 20 minus F of 0 sure looks an awful lot like this. F of 20 minus F of 0. We are going to calculate that by calculating an area. So according to FTC1, this is equal to integral from 0 to 20. Make sure you get the numbers in the right spots. The 20 that came first over here goes on top. You can't always say that the bigger number goes on top. You got to say the number that came first goes on top. Okay, and then I'm just copying my theorem. It said F of t dt. That's it. That's what it says. And in this particular case, I am given the formula for f of t dt. I'll just copy it. All right, so in order to calculate how much oil went through the tank in the first 20 minutes, what we're instead going to do is actually calculate the area underneath this curve. Now, doing that by hand, really, really hard, but the calculator can find the area pretty well, so let's just ask it to find the area. So I've got the graph here. I'll do it the graph way. So 7, lower limit is 0, upper limit is 20. It's going to shade in the oil because it's going to be black, so it actually gives you a nice visual of the oil flowing through the pipe in the first 20 minutes. So it stops there, about 27.55, and then we'll think about the units here. So this is roughly 27.55, and then the units here, remember we said the units for this are the G units, the output units, times the T units. So it's the output units of this function times the units for that function. So the output unit for this function is gallons per minute. So let's write that. Gallons per minute. But then it goes times the output units for T, output units for this guy, which in this case are minutes. So it's times minutes, and gallons per minute times minutes actually just gives gallons, which is exactly what we wanted. 27.55 gallons is what has passed through in the first 20 minutes. That's using the fact that f of 0 is 0.